Okay, this problem is really ugly. But we can make it simpler. Just like by replacing stuff, right? Because what makes this confusing is like this. Like if you look at it, this number right here is the same as that number right there. And that's the same as that number right there. And that's the same as that number right there. Those are all the same number. Brandon, focus. Come on, turn around. Focus. Turn around. Turn around. Brandon. Forward. There we go. So Carlos, and the same thing with this, right? X plus y, x plus y, x plus y, x plus y, x plus y. Right? They're all the same. So really this is the same as like if we said A was x plus y, right? And we said B was z minus t. By the way, you can get this right without doing this, but it just makes it simpler. And once you get good at simplifying these, you won't actually need to do this step. But it just makes it so you can see what's happening. And the only one I don't like, and I don't know if it's a misprint in the book, I don't know if that really should be a z minus t, because that's the only z minus y.
Yeah.
Huh. So,
I made that C. Let's change it.
you made it c? Yeah. Okay, let's leave it c then. We'll make it c. I wasn't going to, but let's try that. Let's see what happens. Okay. So here's what we got. Then we got 3a to the 10th, good? Divided by 18. Let's see, that's b, right?
Yeah.
B to the 19th. So all we're doing is we're simplifying this by making, like, instead of writing that, we're writing a. And the reason we're doing that is that we're hoping we can see things that can reduce really easy. So that was a. And then that is b to the 4th. And this is a cubed.
Yeah.
And then c. Stupid c. Hate c. And then this is nice because they're all multiplying. So really easy. You can reduce anything from the numerator with anything on the denominator anywhere. Anything in the numerator anywhere can be reduced with anything in the denominator anywhere because it's all multiplication. So 108 a squared b to the 20th divided by 15 b to the 4th a to the 10th. Okay. How do you, there's an old saying, how do you eat an elephant? One bite at a time. This looks like a big giant problem, and it is, but you just can do one little part at a time. It's no big deal. So we just got to be careful. Now, I think that 3 and 18, I think we'll start there. That's 6, right? Okay, and then this would be 5 over 6. Is that good? And then 3 goes into both of those, 5, and then 3 goes into there, 36. Okay. Oh, look at that. A Disney moment. Yeah. Like, in Disney, like, everything looks like it's horrible and we're all going to die, and then in the end, like, magically, something just happens, like 6 times 6 is 36. Oh my gosh. A whole new world. Oh my goodness. What? Look how beautiful and lovely that is. Just like all of you. Especially you, Tristan. All right, Tristan. Do you see how all those numbers just reduced?
Yeah.
You probably wanted to seen that if you didn't, like this substitution helped us with that. They all reduce. They just make 1. They're all 1. Okay. Now let's talk about some A's. There's no wrong way to start this. I don't know, like I'm thinking maybe I'm going to reduce these first and reduce these first, but I think maybe just knowing the kinds of mistakes I make, I think I'm going to combine them all on the top and combine them all on the bottom. That's probably what I think I'm going to do, because nothing seems, like there's nothing jumping out. Like that's a to the 10th here. I don't see an a to the 10th. Oh, yes, get rid of that. Oh, good.
How about the B4?
Oh my gosh, I do see them. Oh, wow. Okay, I take it back. Okay, whoa. That's 3. And that's 3. But I think I'm not going to do that yet.
Yeah.
Because I'm afraid I'm going to start messing up. So I'm just going to, like, math is like dating. Math is like dating. You got to take your time. Otherwise, you do something stupid, and you look dumb, and you get your feelings hurt. All your friends are like, I told you so. Yes, Dylan.
Can you simplify B to the 19 and B to the 20?
We could, but since I got so much stuff scratched off already, I'm just going to rewrite what we have. So I have a and a squared. That's a cubed, right? B to the 20th. Did I miss anything up here?
No.
That's it, right? Okay, now here I got 19. I got a cubed, b to the 19, and c. Is that right?
Yes.
Did I miss anything?
No.
Okay. So these reduce and make 1. That's 19 subtracted from 20 is 1.
What about the A cubed and the A squared? That's amazing. Me too.
C minus 2.
Just hold on. Just think about your question. You'll see it.
That was magic.
Wow.
Okay, before we ask about questions about how we got this far, those of you who are with this, do you guys agree that that's good so far? Did we mess up anything? Okay, now we need to go back and put what B was. B was Z minus T, and C was Z minus Y.
So if it was a T, it would be 1.
That's a good one.
Yeah, if that was a T, this whole thing would be equal to 1.
That is evil.
That it would be evil. All right. Parth? Parth? Hold on, Parth. Parth, here's the thing that would really upset me for you guys. And Brandon's probably going to mess this up. He's having a really hard time focusing today. He's got his body parts on Dylan's desk. It's just bad. Okay, Brandon, look.
Shut up, Dylan.
Brandon, here's the thing that would really upset me for you guys. Like, if you did this whole problem, really ugly and complicated, if you did this whole problem, you got this far, that means you're neat, you're organized, you're thinking carefully, you're making yourself go slow, right? What would really bug me is if you took this and you said, and that would be 1 minus t over 1 minus y, and that's no. You can't. That's not reducing. This is right.
If it was multiplication, you could do that, right?
If it was multiplication, then it would be positive t over y. Yeah, but it's subtraction, and these don't have common. There's no common factor between all of the terms, so you can't reduce that. You're done. Okay, so now let's do a couple questions. We're going to ask Roberto his question first. I knew it. That was funny. He was asking me a question, and I'm like, I think you know the answer to that. And so I just asked him, and he's like, oh yeah, I got that. Now Parth has a question.
Yes. So you said we were working on if there's plus or minus between two variables, and it's the square root. So
That's not about that's totally different.
Yeah. That's
Yeah, that's different. We're not gonna. That's a whole different subject. Yeah, but that's okay. We'll talk about that in a moment. Who else has questions about this thing right here? This hotness. What's up, Diego?
I was gonna say, how come you reduce B20 over B19?
Yeah.
How come you?
Well, aren't those the same base?
Yeah.
What's this 20 mean right here, Diego?
It is. It was multiplying 20 times from its number.
What number? So Diego, okay, here's the thing. I think you know, and you can write it, but since you can't say it, you're really struggling. Because that means this idea in your head isn't like formed. Diego, look at this. This 20 means there are 20 b's multiplying. It would be b times b times b 20 times, right? That's what that means. And this says there would be 19 b's multiplying. So it'd be a whole bunch of b's, right? A whole bunch of b's. But this 19 is one less than 20. You have one extra left after you get done reducing all of them. The shortcut is 20 minus 19, but that's where it comes from. How many of you guys think Amelia should probably really wake up? He's over there getting a little sleepy. Yes, sir, Alex.
Can we do G now?
Alex, do you have a question about this one?
Oh, no.
Mikey, what's your question?
So when you're reducing variables, is there not the same power?
Yeah.
Can you still reduce them or no?
So, no. It's a little different. And variables, they just represent numbers that you don't know. That's all it means. So check this out. Let's talk about it with numbers. Right? Would that be 1 cubed over 1 squared? Because 8 divided by 8 is 1? Would that be true?
No.
Oh,
No.
yeah. No.
They're gonna be
Yeah.
8.
Because you have to subtract the exponent.
Because this is 8 cubed. It's 8 times 8 times 8, and that's 8 squared. That's 8 times 8.
Isn't it because like 8
So
is only one number, it's not addition?
it's order of operations that you're messing up there. If you did this, then you would have violated the order of operations. Reducing is division. That comes after exponents. That's no different than this. You're not reducing the A. You are reducing, but the A's aren't what's really reducing. What you have is you have A times A times A, and you have 2 A's there. Those make 1, and you're left with A divided by 1. The shortcut is 3 minus 2 is A to the 1, which is fine, but that's why.
So like if they're not, even if they don't have the same exponent, you can still reduce them?
Correct.
Oh, okay.
Yeah. Okay. What other questions do you guys have about this hotness? Anna E, do you have a question? You missed a lot yesterday, didn't you? That's why you're my favorite student. All right. All right, let's see here.